In this video, we're going to be discussing using functions. Up to now, everything we have done has been in the main function. For example, on line 19, int main parentheses, ending on line 30. We're going to expand upon that now so we can use functions to encapsulate code that we have that reoccurs. So rather than having cut and paste code that we've copied into our program several times, we can now put all of that code into a function and more efficiently use it by entering the code only once and then calling it multiple times. Let's start out with looking at our normal way of coding. Cout \n, because we want to return this is not in a function. Okay, let's put in a system. Well, we already have a system pause in there. We'll work with that. So if we run our code right now, this is not in it's not in a function. It's in the main function, but it's not in a separate function. So let's run our code, see what that looks like. And we get this is not in a function along with our system pause. Let's begin by creating our first function. So we're going to go above main. I'm going to create a function. Void my function. In this case, it's defined and declared. We'll talk about that in a minute. And declared. We use our curly braces to identify the block of code belonging to this function. The only thing we're going to have in this function to begin with is cout. Oops, if I could type. This is in a function. Fix this up a little bit here. Come over here and we do our end line, our endl. And we have the beginnings of a function. Here we've defined and declared a function. Now the way the compiler works is that when you execute your code, it comes straight through, top to bottom, and learns about what is in your code, or executes what is in your code at that point. So if we're going to use our function down here in main, we have to define and declare it above main in order to use it inside of main. So we have defined and declared it above main. Now we're going to go down, and if we run our code right now, while this code is in here, it won't do anything because at no point has this code been executed, invoked, or called. You'll hear it addressed as any one of the three. But we have not caused this code to execute yet, because you notice in main there is nothing that executes this code, and here we're just declaring and defining our code. So let's run our program. We'll see that it does nothing with my function at this point. So still the same output. Now let's actually invoke, execute, or call. Any of those three terms refer to the same thing, my function. So we're going to type, let's see, we're going to come down, not in the function, come down below there, and we're going to put my function. You see it's already identifying that as with the autocomplete. Do our parentheses because it's a function, it has parentheses. In this case, we have no parameters coming in, and it's a void return, so nothing is coming back. So here we are calling, executing, invoking, I think that's how you spell it, the function. Okay, so we run our code. What we should see now is our normal cout from line 30. It says this is not in a function. Then on line 31, it is going to call or execute or invoke our function, which means it's going to go up here. It says, I know this function because you previously told me about it. So I'm going to run up here and I am going to do this cout that's on line 21. So let's test our code. And in fact, we see this is not in a function. You drag that over a little bit, and this is in a function. So we got our call in main to our cout, which then on line 31 called our function. Our function says this is not in a function. This is in a function, excuse me. So it executed our functions that exist on line 19 through line 22 in our code, and then we exit our program. So that is how we call a function. Now, like I said, you have to define your function, or at least declare your function above main before you can use it. If the compiler comes through sequentially, it says, okay, I know this function, then when we get down here to call it, it actually knows what my function is. But let's see what would happen if we move this below main. So I'm going to move this briefly below main. Oops, Control Z. There we go. So now our function is below main instead of above main. Delete some of that out, close out the window so we can get a better look at this. So we've instead declared and defined it below main, and watch what happens when we try to run this program. It says there's errors. If we look at the error, it says, hey, I don't know my function. So we're looking at the error. It says specifically my function identifier not found, because in the sequence of compiling the program, it got to line 26, and by the time it got to line 26, it says, hey, you're calling something I haven't previously identified or I don't know about. So on lines 33 and 30 through 36, they haven't been seen yet. So let's put them back up above main, and again you'll see our program resumes working normally. Scroll back up, place it back here above main, and again we can execute our program and it works just fine, because again the compiler has identified, seen, and now knows our function, my function function. So when it gets to it inside of main on line 31, it can execute it. Now I want to show you a different way we can do the same thing. This is kind of getting us in preparation for when we start working with classes. We said we defined and declared this function above main, but we can just define it above main and declare it below main. This is very similar to how we'll do when we move into class files, where our header files will contain the declaration for our functions and our definitions will be in the class source file, but that's on down the road here. So let's look at doing declarations and definitions of functions. We said we have to declare our function at least before we try to call it in our main, otherwise the compiler doesn't know what we're even talking about. So let's make some adjustments here. We're going to take and move this back below main where it wasn't working before. Now if we do this again, it would fail, because when it gets down to it in line 28 in our code here, it says you're calling my function. My function doesn't exist. I don't know it because it's declared and defined below main. It's unknown to me because I sequentially have not gotten to it yet. So what we can do is we take the line 35, which is our function header, and we are going to leave the defined part here. We're going to get rid of the word declared down here in our remarks, but we're going to copy that whole line, just that one line, come up above main, paste it up here, and now instead of defined, it's declared. So we have declared a function called my function. The compiler sees that, comes through, says, okay, you've declared my function. We do have to include a semicolon up here because that's ending that statement. So this is the prototype for the function. Says, oh, okay, let me see, do I have that defined somewhere else? Yes, I do, down here at the bottom. My function is defined down here, so it's declared at the top. That kind of tells the compiler, whoa, wait a minute. And it knows now how to find that function, so that when it gets to line 28, using that declaration, it can find the definition of the function. The definition is where all the work goes on. The declaration is kind of letting the compiler know that, hey, we're going to have a function, here's its name, this is what it's kind of going to look like. So let's test this and see if this works. We're going to run our code. And yes, it does in fact work. Let's close out a few windows so we can see our code a little bit better. So we have a declaration for our function and a definition that contains the information about what the function actually does. This tells it what the format of the function is going to look like when we call it, and this tells us what the actual function does. Like I said, the declaration has to end in a semicolon, whereas the definition is contained in curly braces. Now let's take a look at using a function with a variable passed in, or parameter. So we're going to modify our function a little bit. Let's go down to our function. We're going to accept in a parameter of a string data type. Let me make sure we've got the include for our string. Yes, we do. So then line 15, we've got our include for the string. So we're going to pass in a string parameter. So parameters go inside the parentheses. We'll do string. We're going to give this variable a name, str my name. We're going to come down into our function. We're going to make a minor modification. We're going to add some additional code. Cout. And, oops. We're going to demonstrate that we have passed in that string. So we're going to say welcome and use our variable we just passed in, which is str my name, using our autocomplete to my function. And a little bit more here. Whoops. Sorry about that. Indel semicolon. So here we're going to display the output that is passed into the function. We look and we see that we have on line 35 our prototype here is void my function string and a variable name. However, up at the top we notice we now have a green a little squiggly line, and it says basically what it's trying to tell you is this no longer matches that. Your declaration doesn't match the format of your definition. So the easy fix is we copy this line, the prototype for our definition. We come up here and we replace this line at the top where our declaration is. We include a semicolon, and now the declaration and the definition match. Now as we look at line 28, we notice that line 28, where we're calling, executing, or invoking our function, it is now complaining. So we've got a little red undersquiggly, and what it's saying here, if we hover over it, let me see if I can get it to do it. It shows us in the little pop-up that the function prototype says it's a void return, but it expects a string to be sent inside the curly braces for parameters. Parentheses for parameters. And right now our parentheses are empty, so we need to send something in. So let's create a variable up here so we can send something in. So I'm going to create a string variable up here at the top, string. And we're going to talk a little bit about variables and variable scope. So I'm going to create a string called str name, and I'm going to assign it to an empty string. This is our variable we will use for console input. So we're going to come down below our not in a function line, before our my function. We're going to use our console output, cout, and we're going to say \n. Let's do another \n just to make it look a little bit better. We're going to ask, what's your first name? Do our space, end our statement. Then we're going to use a cn, and we're going to get our string variable using str name, because that is the, you notice when we do str name, it knows that. But if I try to do str my name, it does not know that. This is where we talk a little bit about variable scope. str name is str my name, down here in our function, is a variable that belongs to this function. It lives and dies inside that function. Its entire scope, or time to live, is inside this function. Because it is in this function, our main function cannot see it. Even though up here on line 19 we talk about it in the context of it belonging to my function. So its scope is my function. When we look at line 23 at str name, this line 23, This variable lives and dies within the main function. Its scope is inside of main. As such, if we were down here inside of our function and tried to use str name, you notice it does not know it. It knows str my name, but it doesn't know str name because that variable scope is in main. So this is important when you're dealing with functions because you have to know the scope of the variables you're working with. So we're going to use str name, which is in the scope of main, and we're going to get that value. And we're going to take that variable that we just used to get for input from the console, we're going to paste it as our parameter we're passing in our function. So we're going to pass in str name, which will be transferred, or the value will be copied into the local variable for our function called str my name, and it can be used inside of there. But again, this is a copy of the value. It is not actually affecting or modifying the value that's in str name because it's receiving that copy of what's stored in that information. So let's run our program, see what it looks like. Here's our not in a function. My name is James. Here is our this is in a function, which is where we're calling our function down here on line 39. It says welcome to James to my function. That's where we receive the value that was stored in str name from main. It's passed into the local variable for our function called str my name, and it is used for the output on line 42. Close that out. Close this. So in looking at this code so far, we have created a function that has a declaration type that accepts a parameter of a string. We have a definition for that function that accepts that parameter of a string using a local variable called str my name, and then within that function it uses str my name. Now another point to demonstrate here, we could have changed this name to str name, which is the same as what is used in the main function. But what you need to consider is this is a local variable. Oops, str, can't type. This is a local variable to this function, which is not the same str name as this variable, which is local to main. So even if you use the same name, which is a bad idea, by the way, which is why we used str my name, these would still be two distinctly different variables with two distinctly different areas where they live and die. I'm going to scroll up again one more time just so you can take a better look. There's our code before we move on to the next topic. Let's talk a little bit more about variable scope. For the next demonstration, we're going to create a variable declared above main. Any variable declared above main is global to your program. So we're going to create one up here which is a string data type, str player name. This is just for demonstration purposes. We're going to assign it a value of an empty string. So this variable can be seen not only by main but by my function because it is global to the entire program. So let's come down to our program here. We're not going to do anything with str name player name here for the moment. We're going to come down to our function. So in our function, we're going to prompt for a player name. Cout give me a player name. Oops. Name. Colon space. Semicolon. Do a cin. Now you notice the variable that we're going to be using is not declared within my function, but it's also not declared within main. It is a global variable, str player name. So let's use that, str player name. You notice it's happy because the function that we created, my function as well as main, both see str player name. Matter of fact, we're going to input it in my function and we're going to output it after we call my function in main. So we'll do cout your player name is, and we're going to do str player name inline semicolon. We need to probably push that down a little with a couple of backslash n's. Push it down with 3. So we're going to run this code, which is going to use this global variable, which is going to be prompted for a value in our function, my function. And it's going to be prompted here on line 46, but then we're going to display the output after my function on line 35 right here. So we're going to get the value on line 34 using our function and display the value in line 35. So it discusses using a global variable, global variable with both main and our function below. So let's run our code, see what that looks like. So here we are. This is not in a function. That's coming from main. This is not in a function. We are now prompting for a first name down in, before we go into our function, which is on line 32 in main. Now we are in our functions. This is in a function. And we're asking within our function, that's on line 45 and 46. We're prompting for a value to stick into that global variable for a player name. Our player name will be Tex. We hit enter and then we return back to main, and right after our function call on line 34, on line 35, we use our cout to display the global variable str player name's value, which in this case will be Tex. And that is using a global variable with functions. Let's scroll up here for a moment, and right there. Okay, in this section we're going to clean this up, get rid of the global variable for a minute, and we're going to talk about returning values in a function. So I'm going to get rid of that line. We no longer need this. Well, actually we do. We'll leave that, sorry. We're going to take this line out. So now we're just back to our function we had before, pretty much. We look through here, we have our function, it's passing in a string, it's a void type, so that means it's returning nothing, it's receiving a string, and it's using that string to display a message. Well, we're going to modify this return type. We're now going to return a string. We could return any kind of data type, an integer, a void, or double, a float, string. So we're going to return a string in this case. Now since we changed our declaration, we need to change our definition prototype. So this will be a string as well. So now it's all happy. Our declaration matches our definition. We're going to go into a little more detail here in a minute. But we're going to return a value with our function this time. So here we're receiving in a name. We're saying welcome James, but we're going to make a modification. We're going to return a value. So a couple of ways we can do it. We're going to do it directly first. Return, can't spell today. And we're going to take the variable that we received in, str value that we received in my, which is stored in the local variable to the function called str my name. And we're going to concatenate to it a string literal of, comma, instructor computer programming. And we put our semicolon to end our statement. So we're using our return statement to return the value that we were passed in, plus we're concatenating to that a string literal. So let's see how we can use this. Here is our function call. Now we know if we hover over it now, it shows, hey, not only does it accept parameter of a string in, but it should expect a string back. But you notice it's not giving us an error. So right now you have an unassigned return value to your string. Value from that function. We need to assign it to something or use it. Well, we're going to use it, and then I'll show you how we can do it with an assignment as well. So first let's use it. Let's do a cout, and we're going to put an inline after that. And what we should get, in fact, let me put a couple of backslash n's in here just to make it look a little bit better. What you should get is the string value that it returns from this function, which think of it as coming back to the left-hand side of your call to the function, is going to be fed into the, or cascaded into the cout. And you should get the message that we are returning right here on line 43. So let's test our code and see what it does. I can click the right button. So here's James, and it comes back in fact with our return statement. So our function returns James plus instructor computer programming. That is returned to where the function was called. That value, that output, that string value, because of the return type being a string, is returned to our cout. Our cout then displays our message, James, instructor computer programming technology. So you get extra space in there too. We'll get rid of that. So move this over, close this out, and remove that space. And we'll run it again just so you can see it cleaner. James, and it returns James, instructor computer programming. Now this is by direct return, because we can do this. We could actually do, you could do like a math formula here if you were doing like integers or float values or doubles as well. But we could also have assigned it to a string value in this case, because it is a string data type in our function. So we'll do a string, we're going to call it str message, and we're going to initialize it to an empty string. And down here, instead of doing what we did by the direct return, we're going to take that passed in value, and we're going to assign it to str message equals. We're going to take the return type, the return entry here. We're going to move that up here. And we're going to return str message. So here we're returning the value in a variable inside of this function. I don't know what that's saying. Oh, missing a semicolon at the end. Sorry about that. So we're going to store what we previously returned into a variable, and then we're going to return the variable value back to our main function for use in that cout. So let's see that working. It should do exactly the same thing, but this time the only difference is we're using a variable to store what we're returning, and then we're returning that variable value. Run our code. First name is James. Down in my function, it returns str message, which contains James, instructor computer programming. And that is using a return value with a variable. And that is the basics of working with a function. Now let's talk about passing in multiple values to a function, or having a parameter with a function with more than one parameter. Excuse me. So for this, I'm going to create an additional string variable in here, str class number, and we're going to assign it a value of ITSE 1307 C++. I'm going to put an end a semicolon on that. So we have a string that is scope is in main, which means it can't be seen outside of main. So we're going to modify our function so that we can pass in an additional parameter. Do comma string str class, just using that. And we're going to make an additional modification down here to our return statement. Excuse me, the variable that we're returning. We're going to include, let's see, put a dash. We're going to include our concatenate in our variable here for str class. And we see this is the format for our prototype for our function. So we're going to copy that. Because we made a change here, we're now accepting in 2 parameters instead of just 1. So we're going to come up here, and we're going to add in, or change our declaration line, excuse me, by pasting that up here, adding a semicolon to the end, so that now our declaration and definition match. Both of them have 2 parameters in. When we come down to our function call, we notice when we call my function, it's unhappy, and if we hover over it, the little tooltip pops up and says, hey, I'm expecting 2 strings to come in this time. So we need to add our other string we're passing in this case it's a string variable that contains str class number, which will pass in the information from, or the value from, our main variable called str class number to our function, which will go into the value for our str class, and then we will use that in part of the concatenation in line 44. So it should return the name we type in, instructor computer programming dash ITSE 1307, if everything works correctly. So let's see this in action. We'll run our code. My name is James, and in fact our return statement now says James, instructor computer programming ITSE 1307 C++, which came from our passed in second parameter to our function that gave the class name. So that is using a function with more than one parameter. Could you have even more parameters than two? Absolutely. Could they be mixed data types? Could you have a string and an integer or a double? You absolutely could. Sorry, took that off. So you can have any number of parameters within reason, of course, within the parentheses. They could be mixed types, strings and integers, or doubles and strings, so forth and so on. That is using strings with multiple parameters. So in this video we have discussed variables, variable scope, variables time to live. We have discussed global variables. We've discussed creating a void function, functions that receive parameters, functions that have return values. In the next video we'll discuss pass by reference.